Okay, 8.1 we did parabolas. We talked about all the different things with parabolas, focus, directrix, stuff like that. 8.2 we're going to talk about ellipses. Okay, so we're going to be able to find the equation, the vertices, and the foci. Foci is plural for focus. We don't say focuses. Okay, we have to be proper English. Foci of an ellipse. So the ellipse is a set of all points in a plane whose distances from two fixed points in the plane have a constant sum. Wow, is that technical? Okay, the fixed points are the foci, there it is, plural of focus of the ellipse. The line through the foci is the focal axis. The point on the focal axis, midway between the foci, is the center. The points where the ellipse intersects its axis are the vertices of the ellipse, and there you can see the picture. So if an ellipse has a center of 0, 0, you can see everything here, what's happening. Okay. Notice the semi-major and semi-minor axes are simply just the square root of the numbers on the bottom. Okay. And also, the foci, okay, the foci, you can see it's plus or minus c. C squared equals a squared minus b squared. Okay? So what happens is, to find c, you've got to plug in a squared and b squared. We'll do that specific problem, but then you have to take the square root of both sides. Notice here, okay, notice how x squared comes first. The a's and the b's stay the same, but x squared comes first, and what that means is you're going to have an elongated ellipse. That's a terrible ellipse. But if y squared comes first, you're going to have a tall ellipse. Okay? So understand that what order the variables go in make a big difference. So they want us to find the vertices and the foci of the ellipse, and then there's our equation. The first thing you have to do, guys, and I want you to notice something here. Notice how both equations equal 1. That always has to be the case. So when it doesn't equal 1, when the equation doesn't equal 1, we got to make it so that happens. So I've got to divide all these terms by 36. Now 4 over 36 reduces to 1 over 9, plus 9 over 36 reduces to 1 over 4, equals 1. Okay? So the vertices, okay, x squared came first, so the vertices are plus or minus a 0. Well, just take the square root. So the square root of 9 is plus or minus 3. So there's our two vertices, plus or minus 3, 0. Now our foci, so we have to do c squared equals a squared minus b squared. That's the formula we have to use for ellipse. So c squared equals 9 minus 4. Okay, that's a squared, that's b squared. So c squared equals 5, c equals plus or minus radical 5. So our foci are plus or minus radical 5, 0. Okay? Since x squared came first, okay, and our ellipse is centered at the origin, both the vertices and the foci are going to be on the x-axis. And that's all you have to do for that, to find the vertices and foci. X squared came first, so that's how we did it. Now, what happens when we have to find the equation of the ellipse, and they give us the foci, and they say the minor axis has a length of 4, and then they want us to sketch the ellipse. Okay? Okay, so the minor axis has a length of 4. The foci, as you can see, the foci are on the y-axis. So what that means is that y squared is going to come first. Okay? Now, c squared equals a squared minus b squared. Okay? Now, the foci are plus or minus 3, so we're just going to do 3 squared, because we know what c is, that we know the foci. Okay? Now, the minor axis, when they say minor axis, that tells us that the number underneath x squared is going to be smaller. Okay? So a squared equals, well, that's 4. Why do I have another equal sign? That's not good. minus 4. By the way, 4 goes right there because it's the minor axis. Okay? So 9 equals a squared minus 4. So add 4 to both sides. A squared is 13. So 13 goes right here. Now, again, you don't have to take the square root of 13 because you're just trying to find the equation. So we have the equation. Okay? There it is. Now, if I were to graph this, watch. My foci are right here. Okay? And I'm going to label them with an F for focus. All right? Now, my major axis, okay, my major axis is the y-axis. All right? Now, it says the minor axis has length 4. Now, remember, the center point is 0, 0. So if the minor axis is 4, that means we're right there. Okay? -2 to 2. So from -2 to 2 is 4. Now our vertices are 0 plus or minus radical 13. Okay? So the square root of 13 is a shade under 4. So we'll just kind of estimate here. And so now here's our ellipse. That's not bad, actually. Notice how the ellipse doesn't go through the focus. It never goes through the focus. Okay? Also, what you'll find is the foci are always inside the ellipse. For parabolas, they're always inside the parabolas. Okay? So, the fact that the foci were on the y-axis meant the vertices were also on the y-axis. Okay? All right, what happens when the ellipse doesn't have a center of 0, 0? So you can kind of see here, again, notice the difference, okay? If x squared comes first, that means that we're going to have a elongated ellipse, and if y squared comes first, we're going to have a tall one. So they want us to find the standard form of the ellipse whose major axis, okay? That will determine, major determines tall or long, okay? Has endpoints -2, -1, and 8, -1, and whose minor axis has length 8. Now, notice, okay, the y coordinates are the same. See that? Okay, so what happens? All right, so let's find the midpoint of the major axis. Okay? All right, so the major axis had those endpoints. So, -2 plus 8 divided by 2. We're doing midpoint formula for those not listening. Okay? So I get 6 over 2, -2 over 2. So I get 3, -1. Now, the question is, why did I do the midpoint of the major axis? What was the why? Because since I know that this is the major axis, by finding the midpoint, I have actually found the center of the ellipse. Okay? So right now in my equation, I've got x minus 3 squared over, we got to figure that out, and then y plus 1 squared equals 1. Now, notice I put y plus 1 because it's a -1, so it's just opposite. Just think opposite signs. Now, the minor axis has a length of 8. Okay? Minor axis has a length of 8. So, okay, the minor axis, okay, where are we at here? What came first? I'm lost again. All right, x came first. Okay, so we're in this column. Okay, now, again, c squared equals a squared minus b squared. All right. Now, to figure out what A and B are, and by the way, the minor axis, that number's going underneath here. To figure out what B is just 8, the length, divided by 2. So B is 4. You just take the length of the minor axis and cut it in half. So this would be 4 squared. Now the major axis, okay, the major axis is how long? Well, the major axis is 10 units long divided by 2. Well, how did you get 10? Well, do the distance formula on that. Okay? So A equals 5. So I have 5 squared. Okay? Well, cleaning that up, 5 squared is 25 plus y plus 1 squared over 16 equals 1. And there is our equation. Okay, now we have to locate the center, the vertices, and the foci. Okay, so center, vertices, foci. Center's easy. -2, 5. Just look in the parentheses, do the opposite sign. Piece of cake. Okay? Vertices. Now x squared came first. So we're in this column again. Okay? The vertices are h plus or minus a, k. H plus or minus a, k. So that's -2 plus. Now, a squared is 9. Okay? So it's -2 plus or minus 3. Actually, wait a minute. Time out. Back up. Back the truck up. Okay, back the truck up. Sorry. Here's the deal. When they give you the equation, all right, and they want to know vertices, foci, so forth. This is the key point. You look at the numbers on the bottom. Obviously, 49 is bigger than 9. So what happens? This is going to be a tall ellipse because the number under y was bigger. Okay? So what we're going to do is we're going to do h, sorry. So we come back here because your teacher's a moron. Yes, your teacher's a moron, sorry. It happens. Now we're in this column. Actually, yeah. They didn't put y squared first, but here's all you need to know, guys. And I don't know why they did it this way. You can determine tall or long by where the bottom numbers are. Okay? Bottom number's 49. It's underneath y. It's bigger than 9. It's tall. So h, we're going to do h, and then we're going to do k plus or minus b. Now, that means that, that b is 7 because square root of 49 is 7. I'll get this right. Okay, so I've got 5 plus or minus 7. So my vertices are -2, 12, and -2, -2. Okay, those are my vertices. Okay, your math teacher's an idiot. Never mind. Okay, now the foci are h plus or minus k. Whoops. I got to tell you, folks. You may request to have me fired after this. K plus or minus c. Okay, now again, where am I getting this? I'm getting it right here. See that? Okay, I'm just taking the information from this table. That's all. Now, how do I find c? Well, c squared equals a squared minus b squared. So c squared equals 49 minus 9, which is 40. But c, that makes c the square root of 40. So my foci are -2 and then 5 plus or minus radical 40. Now, I really can't do anything with that, but if I were to take the square root of 40 and estimate, my two foci would be -2, 11.32, and -2, -1.32. I already worked this out before. Okay? So those would be my foci. All right, bottom line, okay? How do I know if it's a tall parabola or a long one? Look where the number is on the bottom. Bigger number on the bottom, that variable will tell you tall or long, okay? And we'll do more practice problems with this.